Hey all, this is Shelly. I am going to walk you through journal entry number 5, which is the second part of module 4, or checking the reliability of data. So for this module, we're going to look at some data based on the business data for staffsurvey.save from the Pallant book on page 105 of the SPSS survival manual. And so I just want to take a minute and kind of walk you through the data and show you which we're looking at. We'll briefly start off by showing you that there's 536 cases in this data set. That's very important, and we'll come back to that later. As you can see, it is a survey of some sorts. We're looking at various cities and age groups and permanent versus casual employment status. And then there's various questions with Likert scale type ratings. We're assuming they have to do with satisfaction ratings. And that's the data view. And then we're going to come over to the variable view. And we can kind of see how the data points have been named and what type of data they are. And then we can see some labels for some, just quickly looking at length of service and employment status. And then we can look at levels of measure. So we can see that there's a nominal and a couple of ordinals, but for the most part, these are mostly scale level data. So that kind of gives you an idea of what we're going to do or what we're working with. So to check the reliability of data, the very first thing we need to do before we perform any sort of analysis is to reverse any scores on any negatively worded items on our scale. So in order to see if things are worded negatively, we would need to go back and look at the original questionnaire, because in our variable view, as we can see, the actual questions aren't in, they're not actually ID'd. So we could look through the questionnaire to see what questions, if any, identifiable were negative. And we're focused on questions 1A through question 10A. So it's one section with 10 questions, and each of these 10 questions has 5 possible answers recorded in the data view. I'll click back over here quickly so you can see this data view. And this was section E on the original questionnaire. So in this questionnaire, the questions were not worded in a way that required any sort of rewording of negative responses. However, if you encounter a data set that does require rewording, there are countless videos available on YouTube that show you how to reverse if necessary. So going back to this data, to start the analyzation process, once we have the data, we're going to click on Analyze. And I've actually already done this, so it'll just be a brief overview, and I won't walk through all the steps. But we go through Analyze, and then we're going to go through Scale, and then we're going to come to Reliability Analysis. And what I did here, because we're focused on questions Q1A through Q12, was I went through and I looked for those particular questions, and then I arrowed them over to the items category, because these are the items that we're going to focus on. These are the actual items that we want to check reliability on. So we moved questions 1A through 10A into the items box. In this model section below where my cursor is, we want to make sure that it is listed as alpha. You can see that there are various choices, but for our purposes, we want to stay on alpha. And then our scale label, I just briefly labeled it staff status to go along with our staff satisfaction. And then we come over to the statistics button. And then under the descriptives for category, I clicked all three boxes, the item, the scale, and the scale item if deleted. We're not going to do anything with inner item. And then we're going to come to summaries and click on correlations. We're going to leave the ANOVA table as is with none. We're not going to do anything else with anything here. These are tests that we have learned nothing about yet. We're going to click on continue. And then we're going to go to OK. And then this is the original graph that I came up with. So I was hoping to get a bigger view of it, but we all know that Zoom and I are not the greatest of friends when it comes to recording, and this little menu gives me some fits. But I think we're where we need to be now. So anyhow, after we clicked continue and OK, we created a page of several charts. As you can see, labeled reliability based on this data set. This is the charts we've created. So we're going to go through briefly and take a look at these charts and kind of look at what they mean in an effort to interpret some data. So to interpret data, the first thing we want to do is check the number of cases and make sure that it's correct. So we're going to come right here to our case processing summary, and we're going to see our total cases is 536. You will remember from early on in the video, I pointed out that we had a total of 536 cases, and I asked you to remember that because it would be important later on. Well, this is the point where it's important. So our 536 matches up for 100% of the cases. Had this not matched up, we would have needed to go through and see perhaps where we had some sort of exclusionary error. So then we're going to go to the case processing summary chart. And we're going to take a quick look. Our N, we see that 491 of the 536 were valid and that 45 were excluded. And our little key down here tells us that this listwise deletion was based on all variables in the procedure. So essentially, almost 92% of our cases were valid, which is a pretty solid, statistically significant number. So we'll go with this. The next thing we want to do is to check for some inner item correlations. So we're going to scale down and come to our summary item statistics chart. And you'll notice here that we have inter-item correlations within this matrix. We're going to scan just quickly, and we see that there are no negative values. You'll notice our N of items is 10. That's based on the 10 questions we were working with. And it makes sense that none of these had negative values because none of the questions needed to be reversed, as we noted in the beginning of this lesson. So then we're going to go to the inter-item correlation matrix. And these charts can get confusing, so you can always just kind of scan to see where things are. And until you really get to be a wizard with SPSS, lots of times you just have to scan back and forth. But we're going to come back to our inner item correlation. Again, nothing's negative. We have 10 items which match our 10 questions. Everything positive means that nothing had to be reworded. So where else do we need to check for negative scores? Well, that would be the corrected item, total item correlation. So we're going to come right here, the corrected item, total correlation. You'll notice questions 1A through questions 10A, which is what we worked through. We selected those earlier to check reliability. There's our 10 questions. Notice there's matching up. So we're going to look at our values. They're all positive, which means no negative rewording. The third step we're going to do is something called the Cronbach alpha value. So we're going to come up here and find Cronbach's alpha. And you'll notice this is in the reliability statistics table. And in this case, our Cronbach's alpha is 0.846. Generally, values above 0.7 are acceptable, but values above 0.8 are preferred. This means that with a value of 0.846, we are in the preferred range. Next, we're going to come back down here and we're going to look at the corrected item total correlation values again to check the degree to which item correlates with the total score. So we're going to scroll down the chart, and any total item correlation scores that are lower than 0.3 are going to raise a flag to us because they're going to indicate that the item is measuring something different from the scale as a whole. So if we look through, the only value that measures lower than the 0.3 acceptable range is this 0.246 on question 8A. So what do we do with something lower than 0.3? Well, we're going to keep in mind that this is a question that we may want to come back and look at, meaning that this may not be the best question to use. We may want to replace it with a different question. We may want to omit it altogether from our data source. However, because our overall Cronbach alpha is not only acceptable, it's in the preferred range, we're going to go with the assumption that question 8 is okay. We may remove it down the road, but for now we're okay. Next, we're going to look at the Cronbach alpha item if deleted column, and we're going to compare it with the alpha score. That's right here in this last column. And if any of the values are higher than the alpha, which is the 0.846, you may want to remove the item. So we're going to look through here. And what do you notice? There's only one value that's higher than the 0.846. And if we scroll over and look, it's question 8A, which means that the two areas that we target for scores, the corrected item total correlation is lower than 0.3, and the Cronbach's alpha if item deleted is higher than 0.846, is another flag that we probably want to look at this question. So it raises a red flag that we're going to look at some point down the road. It is important to note, however, that with a small number of items such as this, we only have the 10 to deal with. It may be difficult to get a good solid Cronbach value. And that said, question 8 likely needs some review. That can be done at a later time in another video. You can also look at the mean of the inter-item correlations on the summary item statistics table, looking at the mean, and in this case, it is 0.343 which is not less than 0.3. This is a good sign. And this ends my intro demonstration video for checking basic reliability of data. Thank you for joining me.